Hello everyone, we are here to secure our communications. What that means is our organization needs to provide data security for the data that is stored inside our machines as well moving across the network links. So to get started, we are not just going to start sending data around. Let us make sure that our data is the correct form of data. For example, on my desktop I have this folder title is important, and I've got important folders inside this. So how do I make sure that the data inside them has not been maliciously altered or changed since I last used them? So that's what's called hashing. It's a part of data integrity. So what can I do is I can just open up another program called quick hash, and I can go into the directory and I can select that directory of important where all those files are in and click select. Now if I go, this program is going to hash all those files, and due to the exact weights of data in this file, you will get a specific hash value that correlates to that file, right? So what would it look like if one of those file has been altered? How do I check that? For example, maybe financial records or employee passwords. I can go to an individual file and select this hash program. How about we do in individual employee passwords? So it will give me an hash output, right? Now what can I go is I can just open the employee password and I'll change it by one character. Let's say dragon 0 becomes dragon 00. Okay, so I've changed one character and I'm going to save it, and we are going back into the hashing program. Take a look at this. Now before it was 65 in the beginning and 463 at the end. So let us go to the employee password file one more time and take a look at this. It has been completely changed, and I'm going to paste in here what I expected the hash to be. And you can see the program says that this does not match any previous hash. So if you compare those two hashes, they are completely different by adding just 1 0. So this is data integrity using hashing. What we are going to take a look at next is idea of encryption. So what we want to verify here is that when we move our files from one place to another, it is nice to know that they haven't been modified using integrity or hashing, but it is also nice to know that they haven't been intercepted or viewed. So now we need to encrypt these files. Now what I'm going to do is I'm just going to use an open source program known as 7-zip, and with 7-zip I'll have a look at the important directory, and I'm just going to take a couple of files. How about employee passwords and employee records? Yep, and I'll take these two and I'm going to right click on them and I'm going to put them inside the archive with 7-zip, and this is going to give me some options. The first options will be to name the file. I'm just going to name the file as secure.7zip, and for the password, which is going to be a symmetric encryption password, I'm going to use super secure, and this is going to encrypt the files inside of a new file called secure.7z. And in order to be able to view it, they will have the password, the encryption password of super secure, and since it is the same password we will be using to encrypt and decrypt, that's known as symmetric encryption. I'll click OK, and it's done. So I've got this new file called secure.7z. In order to gain access to it and with the confidential data inside, I'll have to right click it and go to 7-zip and I'd say extract to secure, and from there I'll get my password pop up in order to decrypt the contents, which I'll just put my password here as super secure. You can see it, and I'll click OK, and there it is. You can see I have a new directory pop up, and these are the decrypted, and it has decrypted those files. And now if I wanted to verify that these files have not been altered in transit, I would do that by using my hashing program for data integrity. So cryptography here is going to provide you data integrity, origin authentications, making sure that the data is not a forgery and it actually comes from who it said it came from. Data confidentiality, which is our encryption, and making sure that if data is intercepted, it can be deciphered. And also non-repudiation, where it guarantees that a sender cannot refute the validity of the messages, and they are the one who originally sent it and they have signed off on it.